Hello everyone, in this video we're going to be solving a functional equation. We have f of e to the power x minus 1 divided by e to the power x plus 1 equals e to the power 2x, and we're going to be solving for f, which means we're gonna try to find an expression for f of x. Great, so we're gonna be using substitution to find f of x from here, or f of any variable. Let's go ahead and think about it. How can we use substitution? So one of the ways you can approach this problem is, notice that we have e to the power x and e to the power 2x. So e to the power 2x is actually e to the power x squared. So these expressions are related. So I can just go ahead and replace e to the power x with something. For example, if I set e to the power x equals t, then this gives me f of t minus 1 over t plus 1 equals t squared, because e to the power 2x can basically be written as e to the power x to the second power. Make sense? So we got a nicer expression, and the expression inside the parentheses is actually a rational function. So this is a rational function, and what we need to do is turn it into t, right? But how do you do that? To turn this into a t, we need to compose it with its inverse. Because if you take a function f and it's, or let's say g in this case, because that wouldn't be f, right? If you take a function g and then compose with g inverse, then that gives you the identity function. So this would be x basically. Make sense? But what is the inverse of this function? So you can get into some of the rational function complications. Like, to find the inverse of this function, you can set it equal to another variable like y, and then solve for t in terms of y, and then plug it on both sides, plug it in, and then that's going to give you the inverse of this function. But you don't need to do any of this. There is a much easier way, a more direct way to do this. So let's see how that goes. We have f of, let's rewrite this problem, f of e to the x minus 1 over e to the x plus 1 equals e to the power 2x. Instead of naming e to the x something, how about if we name the whole thing something? So let's go ahead and call this another variable. How about z? Okay, that doesn't mean this is complex, it's just another variable. When you call this z, you get the following: e to the x minus 1 over e to the x plus 1 equals z. So here's the next step. We're going to solve for e to the x in terms of z, which is pretty much the same thing as inverting the rational function that we talked about, but it's going to be more direct. And then we're going to plug it in on the right hand side. So let's go ahead and solve for e to the power x first. To do that, we're going to go ahead and cross multiply here. E to the x minus 1 equals z times e to the x plus 1, and then distribute the z, Remember, our goal is to solve for e to the power x. So let's go ahead and put the e to the x terms on the same side. In this case, it will be better on the left hand side, because negative 1 will be positive on the right hand side. So subtract z e to the x and add 1, and then factor out e to the x and divide by 1 minus z. And this gives you e to the power x in terms of z. Question: do you need to find x? And the answer is no. Well, I'll tell you in a little bit why you don't need to. But if you wanted to find x, like if you're really curious and I'm kind of going crazy about it, like I have to find x. Some people are kind of obsessed, like me. I have some obsessions, obviously. So you can do the following. X is basically ln e to the x, right? So you can basically ln both sides, and that's going to give you the value of x. And then you can plug it in. But that's not needed, because what we have on the right-hand side is e to the power 2x, which is e to the power x squared. Great. and we call this z so that we got e to the x in terms of z. Now let's go ahead and write our expression one more time. Now we have f of z. Let me go ahead and write it down here. F of z equals e to the power x squared, which is z plus 1 over 1 minus z squared. And guess what? That gives you the answer. Isn't that cool? You got the answer pretty much. But do you really want your independent variable to be z? If you don't want that, you can replace z with x, and it doesn't matter. It's not the same x. Sometimes people are, how come you can do that? Yes, you can do it. Those are dummy variables, so you can replace them with anything you want as long as you stay within the domain boundaries, whatever. So you can go ahead and replace z with x, and this is going to give you f of x. So this is the function that satisfies the original equation. If you test it out, you can definitely do that. For example, my goal was to evaluate this, so you can go ahead and evaluate this. So how do you evaluate this, right? All you have to do is replace x with that on the right hand side. So that's going to give you e to the x minus 1 over e to the x plus 1, and then plus 1 divided by e to the x minus 1 over e to the x plus 1 plus 1, and then you have to square it, and then this is going to give you what you want. Because you're going to make a common denominator, that's going to be e to the x minus 1 plus e to the x plus 1. Denominators cancel out, and in the denominator, e to the x minus 1 plus e to the x plus 1, and then the negative 1 and the positive 1, they're going to cancel out, so on and so forth. And eventually, obviously, this is supposed to be a minus sign, by the way. I don't know why I put a plus sign there. This is supposed to be a minus sign, so it's not going to cancel like that, obviously. Let's fix it. So this is going to be e to the x minus 1 minus e to the x minus 1. And then when you cancel these out, of course, squaring will make a difference. Here, 1 cancels out. Here, e to the x cancels out. And then you will get your answer from there. Okay? So hopefully this... Okay, I messed up again one more time. I apologize. So this is a plus sign. That's a minus sign. I don't know why I keep changing it. I'm like, this is the reciprocal. And then finally... Okay. Let me fix it real quick. You're going to get e to the x minus 1 plus e to the x plus 1 divided by e to the x minus 1 minus e to the x minus 1. Ones are going to cancel out. E to the x is going to cancel out. And you're going to get 2e to the x divided by negative 2, which is normally a negative e to the x. But when you square it, it's going to be e to the power 2x. All right? I hope this makes sense. And why did it turn out to be a negative term? But it's squared, so it wouldn't matter. Could we get e to the x? Probably. You can arrange this problem such that when you plug it in, you end up getting e to the power x instead of that. And it just needs some adjustment on the coefficients. But anyways, this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.